analysis, and we're going to see it's actually providing flow data and vectors for the movement that's going on in frame. And the way it does this is, it compares every single consecutive frame against every next consecutive frame, okay? And by doing that, it can extract the vectors in the horizontal and vertical planes for those data.
How does it get spots to follow? Is it just watching brightness levels?
It's watching brightness of the pixels. So the best analogy of this is when you compress a video file. When you compress a video file, what it's doing is it's looking for changes as opposed to static. And the static, it just recodes, right? The changes, it says, oh, there's change. This is all it's doing. It's just going through and seeing what changed. But it's also applying vector analysis to it as well. Now, the next one over here, we're actually going to see a little bit different. And what it's done is it's doing optical flow analysis, but it's actually illustrating it as heat signatures. And what I've done here is, with optical flow, you can actually tell it what areas of the video you want to analyze. So I don't want the total motion of the entire video, I just want to watch her hand when it's out in front of her.
It's watching the changes.
Yeah, exactly. That's why you kind of get that ghost image that it's only giving you what is changing in the frame. Now, that's why everything appears black except her. What's interesting about this shows you that this is fairly cross-disciplinary. Dr. Barbosa is a linguist, and the reason they use this is they look at social synchronization during conversation. And this is what optical flow analysis actually gives us as an output. Typically what it's going to do is it's going to give us velocity vectors for the entire area that you have designated. It's going to sum those for each consecutive frame, and then it's going to give you an output in the horizontal vertical, and then it's going to compute a magnitude for those. So you get, out of any of these observed videos, a very specific signal of what the pixels are doing. And again, this is only in 2 dimensions. However, with my research, I'm looking at how people are performing basically within the same frame. And if you have the same frame for it, then it's just relative motion, so you can make some comparisons for that. Okay. Can anybody guess what they are doing? Ooh, yes. This is basketball dribbling. So you have a class of about 9 students that are dribbling basketball, and you saw one of the little guys come over there. But essentially, you can isolate what they are doing as far as dribbling, and then we can get a very specific signal for those motion, that motion that is going on. And with my data, this works out, with my research, this works out really good. If I'm looking for synchronization, I have signal 1 that I can compare to signal 2 and determine if there's synchronization that's occurring there. And we're going to show that here in a few minutes. Essentially, my 3 experiments deal with how students kind of communicate subconsciously. The first experiment that we look at is college-age students in experiment 1, secondary students in experiment 2, and then elementary in experiment 3. And what I had them do was I had them, it's out of order, I apologize. I don't know why that duplicate. Okay, anyways, so for the beanbag toss, I had students perform a beanbag toss while being observed by other students. They're aiming at this target area. All of the other students are watching them. I was filming them from 2 viewpoints, and this way I could do an optical flow analysis of their movement patterns during their actions in that throwing area.
And what using a 10 cameras you already have?
No, this is actually out in the schools.
Oh.
So this is field deployable. So we're out in the schools filming them doing the throw. At certain points, I had them blocked off, so they couldn't see the throws. And the whole point behind this is that when they could see each other throwing, we should see some type of synchronization between their throwing patterns. And when they are isolated, we should not see that. Currently, this is in data processing, but I'll show you. This is actually my oldest child. This is Sammy, and this is what those 2 views look And we had done some early kinematic analysis on this before we put it into optical flow analysis. And this is what the data actually looks like. So if, at first view, looking at the optical flow data, you would think, okay, they're all doing this. So all the optical flow data should look very similar. And that was what our worry was, that, okay, we're not going to see any change, nothing's going to look different. However, if you look at their signals, these are multiple trials, about 16 throws, we can see that there are definitive signals there. And that's what we're working through right now, quantifying those signals, determining what changed, when it changed, and how it changed. So if subject 3 here changed about trial 7, did subject 1 make some type of change at or about that time as well? So that's where we're at right now with that. That's still in process. The next one is an adaptive two-sided game. And I've just started collecting data on this. And essentially, these are 2 of my volunteer students. If we look at this, they are performing what's called a handball game. And they are competing against each other. And when somebody wins, they move a cone in if they've gotten a point. They move the cone out if they lost the point, making it easier for them as opposed to harder for the people that are actually winning. And we want to see what happens when the game gets a little bit more different. Now, the Vicon will provide us specific data for them throughout the game, and then we get to look to see how their game patterns change over time based on who they're playing. And what we've set up is a round robin tournament. So they're put in groups of 4. They play against the same people over 2 or 3 weeks. And we see how their play changes over time, whether new patterns emerge between the participants, and if we can track them down to when they actually start those pattern changes. Okay, so that one is just a data collection. We just started. Okay, so experiment, I call it 0.5. It actually came before experiment 1. Don't ask me why. It's a long story as to why we're back there. Jay, back in the back, he actually helped me out with this, and this is where some of our really interesting data is coming from. So here we can see we have 2 people that are dribbling head-to-head with each other. So they're dribbling right next to each other. We use optical flow analysis to determine when they were dribbling, how they were dribbling. We wanted to see if certain people synchronize with other people. Now, in other experiments, what they have found is that social rapport or friendship tended to be a very, very big variable for who would synchronize with who. So we did a social questionnaire with this, saw who was friendly with who has the best rapport. And then we wanted to see who actually would mimic with each other. These are the data that we would actually get from it. So region 1, and region 2, and then we'd like to compare it. So this is the correlational mapping analysis that I talked about earlier. Essentially, this is just the demonstration piece. This is a correlational map. These 2 signals are being compared between each other at regular intervals. It's a window correlation. What we can see here is that these signals are identical and then they change. Here we see that the 2 signals are completely opposite. Here we see they are different and then they come together. And this is just illustration to help you guys understand what we're going to see on the next few slides. In this case, we see that, and this is also has time lag. So it is comparing straight across, but it's also comparing back in time and forward in time by a full second. So we can see here's half a second lag, there's a full second lag. So in here we obviously see very, very correlated up front, and then it goes into what we call periodicity. So it's very periodic. They do have moments where they're highly correlated. That goes to the broken clock. Broken clock is right twice a day. Here we can see that it does have correlation at those specific times. Here we see that the signals are not correlated at all, and we get that striping again. And here we see that even though these signals are at the same frequency, they are lagged at this point. They aren't around the 0 time frame. When they came into synchronization, we see that they are lagging behind. Okay, so essentially it means that they are dribbling at the same frequency, but they aren't necessarily synchronized. Okay. So if we look at some of our data from our dribbling trials, and what's important to understand is they did 3 trials with each pair. Now these trials were not consecutive. So for instance, Bill and I might have been paired up, and then Jay and I were paired up. But we didn't do it consecutively. I didn't do my 3 trials with Bill, and then go and do my 3 trials with Jay. Do my 1 trial with Bill, then I'd go with Jay, then somebody else and I would come back around. Okay, if we look at the results of this. This is for subject 2 and 6. We see definitive synchronization during the first trial, definitive synchronization during the second trial, and this is actually really good. This is what you would look for. Okay, what this means is that they were unsynchronized, we have periodicity here, and they came back in. This is a correction. This is a deliberate correction by the participants to synchronize their dribble. Okay? Here we see that they are going back and forth between synchronization. Here they were off and they came back in, and then during the third trial they were heavily in synchronization.
And we're both doing this for almost a minute.
For a minute, yes, they were dribbling for an entire minute.
Did they know you were looking at synchronization or correlation?
Nope, I just told them that I was dribbling, that they were dribbling.
Yeah.
Okay? The next one we can see, trial 4 and 6, not synchronized at all. Highly periodic, and you can see that one was dribbling very fast, one was dribbling very slow, and they did not care. So no synchronization. And one more, we can see 1 and 2. Again, we see no synchronization during the first 20 seconds of trial 1, followed by heavy synchronization. The second trial, again, this is really good. This is exactly what we've been looking for. We have synchronization, a collapse. So something happened there. Maybe one of them dropped the ball, and then they came back into synchronization right at the 0 lag. And then again, right there is something that we would really be interested in, that they self-corrected at that point.
Those are probably off. Do you think they had to make correction of dribblers?
Something, yes, there was some type of correction, but what's really interesting is that they came back into synchronization.